Hello, everybody, and welcome again to re:Invent. My name is Aditya, and I'm a software development engineer with Amazon Web Services, where I help maintain the AWS SDK for JavaScript. Today's talk is about building cross-platform applications using the SDK. I thank you all for taking the time to be here, and I hope you enjoy yourselves. So it's been about 2 years since we started building the SDK, and here are a few of the interesting things we've done in that time. In 2012, we released a dev preview of the AWS SDK for Node.js. A year ago, we released a dev preview of the AWS SDK for JavaScript in the browser. Earlier this year, we announced general availability of the AWS SDK for JavaScript in Node.js and the browser. And now we are showing you that the SDK can be used to build applications not just for Node.js and the browser, but for virtually any platform or environment that implements a standards-compliant JavaScript runtime. This is important for us as developers today because JavaScript is everywhere. It has evolved from being a misunderstood programming language to a popular high-level language that is being used to build scalable real-time applications. This growth of the language has also been complemented by the introduction of alternative JavaScript environments that allows us to use JavaScript in so many more interesting ways. For instance, you can build applications using JavaScript and HTML and compile them down to native mobile iOS and Android applications using tools like PhoneGap and Ubisa. You can also build applications for Windows desktops and phones that execute on the Windows runtime. And more recently, JavaScript is being used to build applications for microcontroller devices like Arduinos and AR drones using libraries like Johnny5 and Cylon.js. So having said that, in this talk, I'm going to introduce you to building cross-platform applications using the AWS SDK for JavaScript. To give you an idea of things to come, we'll begin by looking at a sample application. We'll then talk about some of the features of the SDK that we've used to build this application. And then we'll go ahead and port the application to other environments and platforms and talk about some of the differences involved in doing this. So what I'm about to show you is a video transcoder application that transcodes or converts videos from one format to another. The application uses two AWS services, Amazon S3 and Amazon Elastic Transcoder. Amazon S3 is an object storage service, and we are using S3 to store video files. Amazon Elastic Transcoder is a service that allows you to convert or transcode media files from one format to another. Now, our application uploads files to S3, kicks off a transcoder job, waits for the job to complete, and then downloads the transcoded files back from S3 again. So let's go take a look at it. So what I'm doing is I am providing the path of a video that I want to use, that I want to transcode. So our application is now uploading files to S3. It's going to kick off a transcoder job, and now we are waiting for the files to transcode. And while this is happening, I'd like to let you know that the source code for the sample application is available on GitHub at github.com/AWS-labs/AWS SDK.js sample video transcoder. That should be pretty simple to find. I encourage you to go ahead and download it and play with it, and maybe even add to it by sending us a pull request that we'd be happy to look at. So let's go back and take a look and see if our application has finished transcoding files. So you see that it waited for a while to finish, for transcoder to finish transcoding the files. It then notified us about that, and it went ahead and downloaded the files back for us. So I'm going to open this up. So That's the downloaded video.
The keynotes on Wednesday and Thursday are the time when you'll get the chance to hear about the latest trends in cloud computing and see what that means for AWS. Whether you watch live or you watch the stream, you do not want to miss the keynotes this year.
So what you see here is a very high-level architecture of how we've built the application. The bulk of the business logic as well as the lower-level SDK calls are contained in the app.js file. What we've also built in is a very simple publish-subscribe messaging system that allows the application to publish messages that other components can then subscribe to. This allows the business logic to be completely decoupled from presentation. And in order to port the application to other environments, all you'll need to do is swap out your UI layer and then subscribe to the messages that the application is publishing. We'll go ahead and talk about some of the features of the SDK that we've used to build this application now. Here is some basic usage of the SDK. Now, the AWS object itself exposes a constructor for every service that is supported. And in order to send requests, you'll need to construct a service object and then invoke an operation on it. Now, operations are nothing but methods on the constructed service object, and most methods accept two parameters. The first being a params object that contains data that you want to send along with your request. And the second is a callback that is invoked when the request completes. The example here shows us constructing an S3 service object and then making a list objects operation on a bucket that we are passing in as the parameter. So from the previous example, if we don't pass in a callback to the operation, then what we get is a request object that hasn't been sent yet. Now, this is really useful because you can now customize the object before actually sending it. The code snippet here shows us attaching additional event listeners to the success event of the request object. There are also many other events that are emitted during the lifecycle of the request, and you can take a look at these. Are documented on our SDK documentation page, and you can go ahead and take a look at them there. Point to note, however, is that since the request object hasn't been sent yet, you'll need to manually send it using the send method. This is actually useful because it now gives you complete control of your request object. In addition to all the lifecycle events that are emitted by the request, there are two special events that are emitted, and these are the HTTP upload progress and HTTP download progress events that are emitted during data transfers. The event listener to both of these events receives a progress object that contains information about the total number of bytes transferred, as well as the content length of the request or response. Another very useful feature of the SDK that we've used in our application are resource waiters. Now, waiters make it really simple for you to work with asynchronous resources. Very simply, what a waiter does is that it polls the resource until it is in a desired state, and then invokes a callback. So in the sample application that you saw earlier, we used a resource waiter to wait for the job to complete before we downloaded the files back to disk again. There are several services that support waiters, and to know more about these, you can check out our SDK documentation page online. Let's now go back to our application and look at the workflow in a little more detail. The first step in the application workflow is to create a pipeline. Now, Amazon Elastic Transcoder uses pipelines to create jobs. It's nothing but it's similar to a queue. Our application then uploads files to S3 and creates a transcoder job pointing to the files that it just uploaded. As soon as the job is created, our application attaches to the waiter attaches a waiter to the job that was just created, and then polls the job until the job is complete before downloading the encoded files back from S3 again. Now, in Node.js, The console.js file contains all of the logic that is required to interact with the UI. The UI, in this case, being the command line interface. There are some steps involved in, however, in getting the application to run on Node.js. The first of them being getting and installing the SDK itself. And on Node.js, you can do this using the npm install command. Now, before the SDK can be used, it requires credentials to be configured. There are many ways of configuring credentials, but we recommend that you use the shared credentials file. And this is for a couple of reasons. Firstly, the shared credentials file is shared by other AWS SDKs like Ruby and PHP, as well as the AWS CLI. And so it now serves as a single point of configuration. The second reason is because the shared credentials file supports profiles, which are nothing but credential pairs that possibly grant different access to different resources. There are many other ways of also configuring credentials, and to know more about these, you can check out our developer guide online. Now, a little while earlier, I mentioned that we built a very simple publish-subscribe messaging system into our application. So the code snippet here actually shows the application publishing 2 messages when a transcoder job has been completed. We then subscribe to these messages in the console.js file. And specifically here, you see us subscribing to the request success and the job complete message, which then allows us to print notifications to the console. And this is a very simple process.stdout command. We are also able to download files when the job complete event is fired. And we're doing this using the get object operation on an S3 service object. Point to note, however, is that we're using streams to download files and not buffering into memory. The create read stream method on a request object returns a node stream that you can then pipe into another writable stream, and that's exactly what we're doing here. So we've got the application up and running on Node.js fairly simply, very easily. But why should we care about making it portable? Well, firstly, portability means that you now have a single code base that is easier to maintain. It also means that you can now build, test, and deploy and debug your applications on an environment of your choice before porting it to other applications. And this is a huge degree of freedom because environments differ in their ease of use. Portability also means that you can now easily refactor your applications. For instance, you may want to convert a heavy client application to a web service, or vice versa. So any application that can be written in JavaScript will eventually be written in JavaScript. Jeff Atwood actually blogged about this in 2007, and he actually called it the Atwood's Law. What is more interesting is that we've actually seen this happen over the years. A large number of applications that were previously written in other languages today have more popular JavaScript counterparts. So let's go ahead and spread the word by porting our application to other environments. The first on the list is a web application, a traditional web application. I don't have a demo to show you here because we're sort of short on time, but we will talk through it. In the web application, the view.js file would contain all of the UI logic. In this case, that would include things like DOM event management and drag and drop and so on and so forth. There are some differences, however, in the way that you would approach building a web application as compared to Node.js. The first of them being the way you would include the SDK itself in your web application. We recommend that you use Bower, which is a package manager for the web. It is analogous to NPM for Node.js. There are also several other ways in which you can download and include the SDK with your web application. And these are documented on our on our developer guide online. We also recommend that you use Amazon Cognito to manage identity and credentials in your web application. To know more about how to use Amazon Cognito, I encourage you to check out the session MBL401, which is social logins with mobile applications using Amazon Cognito. I think that's happening at 3:15 today, so I strongly encourage you to check out that to know more about how to use Amazon Cognito. That being said, do not use local storage to store any information. This is because local storage is only isolated on a per domain basis, which means that if you have multiple applications on the same domain, then they will have access to each other's credentials. So you definitely don't want to do that. Another difference in the way in porting an application to importing a Node.js application to the web is the necessity to configure CORS on Amazon S3 buckets. Now, CORS is a web standard. CORS, or cross-origin resource sharing, is a web standard that dictates how web pages access resources in external domains. Amazon S3 requires that you explicitly set CORS permissions on every bucket that you want to access. And so you'll have to do this in your web application in order to access S3 buckets from an external domain. You, of course, won't need to do this if your application is also on S3. For an example on how to configure CORS, you can check out our developer guide online, where we actually have a sample CORS configuration that you can use to configure your S3 bucket. Now, in our console application, we log progress to the command line, which was a very simple print.standardout command. In our web application, we use a very simple HTML progress element to display progress. But you can definitely also get a lot more fancy and use a third-party library like jQuery UI to display progress notifications. The key point here is to, however, subscribe to the progress messages that the application is emitting. So that's the key point in displaying progress notifications. Similarly, for generic notifications, we've used a simple div element to display notifications, but you can also use, there are a number of third-party libraries that you can use to do notifications, like Notify.js and Mini.js. Again, the key point being is that you have to subscribe to these messages that your application is publishing. Next on the list is a Google Chrome extension, and I do have a demo to show you for this. So this is our Google Chrome extension. You can configure options using the options page. I'm not going to open it up right now because it contains sensitive information, my information. OK, so apparently desktop notifications don't show up on full screen mode. But you see, I'm going to actually get out of full screen mode. So you see two notifications were created. The first was a progress notification, which showed us which showed the application uploading a file to S3. And the second was a notification that said that, hey, the job with so-and-so ID has just been created. We'll now have to wait a couple of seconds for the application to finish encoding the file, and there it is. So we see another notification that says that, hey, your job is completed. And now we have access to the file here, which I'm going to open and show you right here. So
the keynotes on Wednesday and Thursday are the time when you'll get the chance to hear about the latest trends in cloud computing and see what that means for AWS. Whether you watch live or you watch the stream, you do not want to miss the keynotes this year.
OK. So in the Google Chrome extension, the UI.js file contains all of the code that deals with event management and the lower-level Chrome extension API calls. And the options.js file contains code for credential and configuration management. We haven't changed the app.js file at all. If you look at the GitHub repository, then you'll notice that the app.js file hasn't changed at all. We've made absolutely 0 changes to this file. And though the Chrome extension looks very similar to the web application, there are some fundamental differences in the way it works. Firstly, and the first of these differences is the manifest.json file itself. in a Google Chrome extension, you can use the manifest.json file to whitelist domains that your extension is talking to. When you do this, the Chrome extension no longer treats the domain as external, and so CORS rules don't apply in that case. So if you're using this application on a Google Chrome extension, then you no longer need to configure CORS permissions on S3 buckets. To save our configuration, we are using local storage. This is fairly safe with a Google Chrome extension because local storage is isolated on a per extension basis, which means that other extensions that you may have installed on Google Chrome will no longer have access to will not have access to your credentials and configuration. And the code snippet here shows us doing just that. Another fundamental difference in the way the Chrome extension differs from a web application is the notification API itself. Now, Chrome extensions expose a very rich notification API that you can use to create different types of notifications. And we've used the notification. So the code snippet here shows us creating a basic notification using the Chrome extension API. But we've also used the Chrome extension notification API to create progress extensions. And to do that, you'll need to change the type of the extension from basic to progress. The create method itself is asynchronous, so it returns a notification ID that you can use to then keep track of the notification. So in case of a progress notification, you don't want to be creating a new notification for every progress event. You want to update the same notification, and you can do that by using the notification ID of the notification itself. The last demo I have lined up for you is an application for Windows RT. So the UI looks fairly similar. So you see progress notifications, you see toast notifications, and this is actually running on a Windows machine. This is a Windows 8 application running on a Windows machine. We'll need to wait a couple of seconds for it to finish encoding the file. So we see that the transcoder job has finished, and we have the file now. Let's go ahead and play it. OK, so I don't think I have sound because I don't have access. I haven't turned it on my remote machine. But it is essentially the same video. So in the application for Windows RT, there are 3 core files: home.js, progress.js, and transcoder.js. Home.js contains code that deals with all of the UI and layout that you just saw, which includes code for event management, file pickers, and so on and so forth. Now, progress.js file contains code that contains a very simple progress manager that we've written to keep track of progress events and notifications. Transcoder.js contains code that deals with credential management and configuration. Again, the app.js file has not changed at all. We have made literally no changes to our business layer. We are just porting this as is to a Windows 8 application. So for those of you who don't know what Windows RT is, Microsoft describes it as a modern Windows API surface that is used to create new Windows Store apps for Windows 8. But very simply, what it is that it's a unified runtime that allows you to build hybrid applications. So for instance, you can build part of your application in C# and part of your application in JavaScript and mix and match. And you still have access to the same API that is exposed by the Windows runtime. So that's really powerful because you can build a variety of applications, and that's what we've done here. Now, the way we've handled credential and configuration management in our Windows 8 application is slightly different. And this is because the Windows runtime itself exposes a sophisticated API for managing credentials. It's called the password vault. So the way you would do that is you would create a new password vault and create a password credential with your access key ID and your secret access key. And you would then add that credential to your vault. Now, the vault, again, is very similar to, it's isolated on a per application basis. So other Windows 8 applications that you may have installed will not have access to this information. This vault is also encrypted, so it's not plain text, and it can't be read by, it's not human readable. We've managed configuration using the application data.local settings API, and the way we do this is we create a composite value, which is very similar to a JavaScript object, and we take all of our configuration, bundle it up into this composite value, and then store it on the local settings API. And the way to do this would be to set it using a key, and it's nothing but a JavaScript object, so you would just set it like you would use it exactly in the same way that you would use a regular JavaScript object. Again, for progress notifications, we've used Windows 8 the Windows runtime itself allows you to build JavaScript and HTML applications. So we've used a very simple progress HTML5 progress element to display progress notifications. And in addition to this, we also have, like I mentioned earlier, some progress manager code that allows us to keep track of each progress element and the corresponding files that are being uploaded. So the progress manager allows you to map your progress notifications to the files that are being uploaded. Again, all of this code is available on the GitHub account, so you can go ahead and download it and play with it and add to it and use it the way you want to. It's licensed under Apache 2.0, I believe. So we've talked about progress notifications, generic notifications, that is things like, hey, your job's been completed and your request is now successful. Those sort of generic notifications are handled using the toast notification API. The Windows runtime itself doesn't support progress notifications. There is no native API to deal with progress notifications, and so we use the toast notification. So we've built our own progress notification API of sorts, but we're using the toast notification API to display generic notifications. The way you would do this is you would get a template object, populate it with the content that you want to display, get an instance of the notification manager, that is your desktop notification manager, and then use the notification to show the notifications that you've just created. Now, that's all the demos I have for you today, but here are some key takeaways from this talk. So we've seen the SDK work across multiple platforms and environments, and there are some differences in the way you would include the SDK itself with these different platforms and environments, but it doesn't require any other effort. Also, it is absolutely essential for you to separate your business logic from your presentation. This allows you to port your application to multiple platforms without having to change your business logic itself. What we've used to help us achieve this is a very simple message passing system that we're using to communicate with UI components in different environments. And what you'll also notice is that when you port your application to multiple environments, there are a common set of differences that you will encounter when you do that, and these may include things like the way you keep your users notified of progress events, the way you deal with files, native support for streams, and so on and so forth. I'd like to end this talk by talking a little bit about community and keeping in touch. So the SDK itself is open sourced under the Apache 2.0 license, and it's available on GitHub. at github.com/AWS/AWS SDKJS. And we really like contributions, so we encourage you to contribute to the SDK. You can contribute in many ways. You can submit issues. You can also create feature requests. And if you want to go ahead and fix an issue, then you can send us a pull request that we'd be happy to take a look at. You can also stay connected to us. On Twitter at AWS4JS, and stay up to date with the things that we're doing by following our blog at blogs.aws.amazon.com/javascript. I also request you to please give us feedback on this session using the session ID DEV306. So let us know if you liked it or how we can improve. With that, I'd like to thank you again for attending this talk, and I hope you enjoy the rest of your day.